Okay. So one of the last things that you're doing this week are systems of equations. And if you have to go on to pre-calculus, you are going to deal with systems of equations for 2 weeks. You're going to do it in week 2 and in week 3. Week 1 is like review of college algebra stuff. So this is definitely kind of bringing you into pre-calculus. And this is helpful even if you don't have to take pre-calculus. Systems are very common in business. It's basically where you're graphing multiple things and then you're comparing them and trying to find like a break-even point in business would be an example of a system. So what I'm just covering just today is how to identify solutions. I have other videos for how to solve systems, and you can solve by graphing. There's a method called substitution, and then there's a method called elimination, but we're going to just identify solutions. So a system is what we call when we have 2 or more equations and we're considering them as a whole. And so we're looking for an answer that works in all of the equations that we're considering. So if you have 2 equations, you're looking for an ordered pair that is a solution to both. And this is essentially the intersection between the 2 equations. We're going to be looking mainly at lines, but you can have equations. You can be looking at an intersection between like a polynomial and a line, or a rational function and a polynomial. You can do any type of equations, but we're usually looking at just lines. So we're just looking at where 2 lines intersect, and that is the solution to a system. So if you are given a system, so a system is always written with this curly brace, and then the 2 equations inside the curly brace indicating that these are considered together. And so we've got 2 equations of a line. These are in slope-intercept form. If you want to see if these values are solutions, what you need to do is you plug in your ordered pair into both equations and see if it works in both of them. And if it works in both of them, then it's a solution. So we're going to just test 3 different ordered pairs here. Normally, if you're solving, you don't guess and check like this because it would take you forever to find the solution. There's actual methods for solving, but if you just want to check, is this a solution? You just plug it in and you have to check both equations. So our first one is -1, 13. So that x is -1, and then the y is 13. So we're going to be replacing x and y in both equations. So the first equation we have is y equals 8x minus 5. So if I'm replacing my y, that's going to be 13, equals 8 times -1, and then minus 5. And so first we need to check, does this ordered pair work in this equation? If it doesn't work in the first equation, then we don't even need to bother checking the second equation because it's certainly not going to work. So you're just checking, does the left side equal the right side? So on the right, we have -8 minus 5, which we get 13, and this actually comes out to a -13. So because this ordered pair does not work in the first equation, we don't even need to bother checking the second because it has to work in both. So if it doesn't work in one of them, it's not a solution. Because we got something that's false. 13 does not equal -13. So that is a big X. That is not a true statement. So let's move on to our next point. We have -1, 1. So let's check it in the first equation. So our X is -1 and our Y is 1. So this is going to be 1 equals 8 times -1 minus 5. And so 8 times -1 is -8 minus 5. And you can see, again, this is just not going to work because now we have 1 equals -13. Well, that's, even more bad than what's worse than the first one. Our first point, at least it was the same number, just opposite signs. This is not even close. 1 does not equal -13, not even close. So again, that is not a solution. So now let's see if we can check this next one. So we got 2 and 11. So we're going to have 2 for x and 11 for y. So I'm going to put it in the first order, or the first equation. So we have 11 equals 8 times 2 minus 5. So 8 times 2 is 16 minus 5. So 11 equals 11. So that works. So that's good. So now if it works in the first equation, now we need to check, does it also work in the second equation? So now I'm going to put it into the y equals 4x plus 3. So y is 11, and then we have 4 times 2 plus 3. So 4 times 2 is 8. And then 8 plus 3 is 11. So we get 11 equals 11. So it works in the first equation and it works in the second equation. So since it works in both, it is a solution. Now, in general, if you have a system of linear equations, you've got 2 lines and they're going to intersect, they're only going to intersect at one point. So there's generally only one solution to a system that of 2 linear equations, because they're only going to intersect at that one place. There's not going to be more than one place where they intersect unless it curves, and then they're not lines anymore. There are some special cases where you could have more than one solution. So before I talk about that, are there any questions here? Okay. So there are basically 3 different categories of solutions when you have a linear system. So specifically 2 lines. So we just saw one where there was one solution. They intersect at one point. And I should not have done yellow here. This is terrible. I don't know what I was thinking when I did yellow for my table. But they intersect at one point. So they're basically, like crisscrossing. In order for 2 lines to intersect, their slope is not going to be the same. So you can tell that 2 equations, if they're in slope intercept form, have a solution if they have slopes that are not the same. And we call this type of system consistent. It's consistent because there's a solution, and then independent because they're 2 separate equations. So if you have more than one solution, then the next option is to have infinite many solutions. And this happens if they are 2 identical lines. So if you graphed one of them and then your second line is right on top of it. So they actually create the same line and they're just basically on top of each other. So that means they're intersecting everywhere, which is why there's infinite solutions. So if your 2 equations are in slope intercept form, they'll be the same. They'll have the same slope and they'll have the same y-intercept. That's how you can tell that they are identical. They'll look identical when they're in slope intercept form. So this type of system is consistent because there is solutions, but it's dependent because they're not 2 different equations. They're the same equations. And then the last possibility is that there's no solution at all. And this is when the lines are parallel. And parallel lines don't intersect, so they're never going to cross. And as we learned earlier, parallel lines have the same slope, but their y-intercepts are different. So the difference between having infinite many solutions and no solution is whether they have the same y-intercept, because they're both going to have the same slope. It's just a matter of what do the y-intercepts look like. So if you have same slope, different y-intercepts, that means they're parallel lines. And of course, all of these have to be in slope intercept form for you to really determine how many solutions there are. So if there's no solution, it's called inconsistent because there's no actual solution, but the equations are independent because they're still two different equations. So we're basically going to be determining how many solutions something has based off of what the equations look like. And then I'm going to bring up Desmos to kind of verify that. So we're going to look at the one on the left here. I've got two equations. These are in slope-intercept form. So y equals -1/2 x minus 5. And then y equals 3/4 x minus 10. So to determine how many solutions there are, you really want to first determine what the slopes are. So what are the slopes for those two lines? This is good practice because you'll need to know this for your final exam. So you can go ahead and type in the chat what the slopes are. Or you guys can be really shy and not want to participate, which is okay. I'm not going to force anybody. So first equation. So if I call this line 1 and then line 2. So slope-intercept form, we've got y equals mx plus b. The slope is the number that's in front of the x. So when you're in slope-intercept form, you're just reading the equations here. So our first slope for line 1 is -1/2. Our second slope, so line 2, that's 3/4. So the slope, when it's solved for y, that's slope-intercept form. Your slope is just the number in front of the x. So these slopes are different. And if the slopes are different, that means there is one solution. So M1 is not the same as M2. So this means we have one solution. So this means that these two lines intersect at one point. So I'm going to bring up Desmos and I'm going to type in these two equations. And then we'll see where they intersect. So when you want to graph these, you're going to graph them separately. So your first one here is y equals -1/2 x minus 5. Oops, not 54. And then our second one is y equals 3/4 x, x minus 10. So you can see they intersect. This would be the solution. So the solution to this system would be 4, -7. So, and if you zoom out, that's going to be the only place where they intersect. So there's only one solution because these are lines. They're not going to curve back and cross over each other again. They're going to cross only at one spot. And this is because they had different slopes. So different slopes means that we have one solution. Now let's look at the equation that we have in the middle, the system that we have in the middle. We've got x plus 2y equals 4, and then y equals -1/2 x plus 2. So in order to determine how many solutions there are, we need to have our equations in slope-intercept form. So they need to be solved for y. The second equation is solved for y, and we can see that we have a slope of -1/2. But the first equation is not solved for y. So we want to actually take that equation, solve it for y, and then determine what the slope is. So we have x plus 2y equals 4. And to solve for y, I need to first subtract x from both sides, because I want to get the y by itself. So this gives us 2y equals 4 minus x. And then we're going to divide everything by 2. And we get y is equal to 2 minus 1/2 x. So our slope is the number that's in front of our x. So we have a slope of -1/2. We also have a slope of -1/2 in our second equation. So our first system, our slope is -1/2. Or the second equation, the slope is -1/2. So these have the same slope. So if they have the same slope, then we have to look at the y-intercepts, because we're either going to have infinite solutions or we're going to have no solution. It depends on whether they're parallel over the same exact line. So we need to look at the y-intercepts to see if they are the same. So what are the y-intercepts for these two lines? So we have y equals -1/2 x plus 2. And then we have y equals 2 minus 1/2 x. So what are the y-intercepts? You only need to read it off of the equation, because the equation is in slope-intercept form, so it's giving us the slope. It's also giving us the y-intercept. So the slope is m. The y-intercept is b, the number that's added on. So we have a y-intercept of 2 in the second equation. We also have a y-intercept of 2 in the first equation. They have the same y-intercept. So we've got the same slopes of -1/2. And then we have the same y-intercepts of 2. So B2 is equal to 2 and B1 is equal to 2. So they have the same slope. So M1 equals M2, and the y-intercepts are the same. B1 equals B2. This means these are the same lines. And so if they're the same line, that means we have infinite solutions. Because that means that these lines are basically going to be graphed one on top of another. So if I go back to Desmos here, see, our first line is x plus 2y equals 4. So that's the green line. And then I'm going to graph our second one, y equals -1/2 x plus 2. And that's the purple line. And you can see the purple line is right on top of where the x or the green line was. So we had a green line, and then I add in the purple, it's right on top. So it's intersecting everywhere. So there are infinite solutions here because these are the same lines, even though they don't look like it when you're initially looking at your system, they're actually identical. And so every point on that line is a solution. So now we want to look at our third system here. We have 2x equals y plus 4. And then negative 4x plus 2y equals 2. So in order to determine how many solutions there are, we need to put these in slope-intercept form. And yes, when you're graphing, when you're looking at it, you always go back to the original form, because that's, if you go back to how it was originally written, to make sure that you didn't make any errors when you were solving. Because if I had graphed those and they didn't intersect, that would tell me that while I was solving for y, I made a mistake. So always go back to the original when you're graphing, just to make sure that you didn't have any errors. So for our third one here, we need to solve both of these equations and put them in slope-intercept form. So we're solving for y. So the first equation, I have 2x equals y plus 4. And to solve for y, I want to subtract 4 from both sides. And so I get 2x minus 4 equals y. Then I have my second equation, negative 4x plus 2y equals 2. And so we need to solve for y. So first I'm going to add 4x to both sides. We have 2y equals 2 plus 4x. And then we divide everything by 2. And we get y equals 1 plus 2x. So both of these are now in slope-intercept form. The first one I put the y on the right, but that's fine. We still have the y by itself, solve for y. So we need to check what our slopes are and then check, go from there. So the slope is the number in front of the x. So M1 is equal to 2 and M2 is equal to 2. So they have the same slope. So if they have the same slope, then they're either going to be the same line or they're going to be parallel. And that's where we have to look at the y-intercept. So the y-intercept is the constant. So our y-intercept for one of these is -4. So B1 is equal to -4. The y-intercept for the second one is 1. So B2 is equal to 1. So they have different y-intercepts, which means they're not the same line. So our slopes are the same. M1 is equal to M2. But your y-intercepts, oops, that should have said 2 right there, are not the same. And so that means that there is no solution because they are going to be parallel lines. They're not overlapping. They're going to be the same slant, but they're never going to intersect. And when we graph to kind of check our answers, you're going to be graphing your original equations. So the first one is 2x equals y plus 4. And then my second one is -4x plus 2y equals 2. So you can see that they have the same slant here, but they're not intersecting. It's the same space. The space between them is not changing. So they're parallel. And I can zoom in if you need to see it a little bit better. But these are parallel lines. They're never going to intersect. So that means there's no solution. And you can zoom out and they're never going to intersect. If you zoom out enough, it's going to look like they're overlapping, but they're not. They're never actually going to intersect. And this is because they have the same slope, but their y-intercepts are different. So there is no solution to this system because there is no intersection point. Are there any questions? Okay. So that's all I had. Like I said, this was going to be very short. It's just, if you've got a system, checking and knowing how to tell something is a solution, you plug in the equation or plug in the ordered pairs to check to see if it's a solution, if it works. And then if it works in both equations, it's a solution. Otherwise, it's not a solution. And then the other thing about systems is whether to know how many solutions there are, whether there's one, infinite, or no solution. And that's all based off of slope intercept form. Y equals mx plus b. So when you do that, you need to make sure that your slopes or your equations are solved for y in order for you to check. So like here, m1 is not the same as m2. m1 equals m2 and b1 equals b2. And then for no solution, m1 equals m2, but b1 is not the same as b2. So it's all about looking at those equations, determining if the slopes are the same, and then if they are the intercepts the same? And that will help you determine how many solutions there are. So that is it. Nice and easy.